Good afternoon, my dear students. In this session, we'll discuss about distinctive behavior of lithium and chemical properties of alkali metals. Lithium is placed in alkali metals, but lithium contains some unique character compared with other alkali metals. So why? Because of the smaller size of lithium, that means atomic size smaller, and high polarizing power. High polarizing power and high hydration energy. High hydration energy. And there is absence of d orbitals. So in present, in this series only they contain s orbital in the valence shell, but the elements which is present in that series, lithium, sodium, potassium, rubidium, cesium, they have some elements contain d block element, p block elements also, but in this lithium they not contain, they don't have d block element, d orbitals. Okay, so that's why absence of d orbital, absence of d orbital. So we have four character of the distinctive behavior of lithium. What are they? Atomic size smaller atomic size, we know that because it is placed in the top of modern periodic table next to hydrogen. The next one, high polarizing power. So they have high polarizing power. That means if it is combined with some other compounds, it will show the polarizing, the high polarized one. Okay, so they give the high polarized power. Then high hydration energy. That means this lithium combining compound have high they have more power to dissolve in water. So high hydration energy. Then absence of d orbital, there is no d orbital to fill the electrons because only 3 is atomic number. This is electronic configuration. So only s orbital is present in lithium. So because of these four characters, this lithium is behave individual in this series alkali metals. So when we compare this lithium with other elements in this group or the other elements of this alkali metals, comparing properties of lithium with other alkali metals. So we can divide this in two parts. First part naming as lithium, second part other metals or alkali metals other than lithium. In this table, we differentiate the properties of lithium with other metals. That means from the group 1, so alkali metals. So the first property of lithium, the comparison between lithium and other metals. Lithium is a hard element. This is a hard element or hard metal, we can say, hard one. So other elements, soft. They are soft metals. And lithium has high melting and boiling point. So melting point of lithium and boiling point of lithium is high. boiling point. So this is the opposite for the other metals in alkali metals, that is here it is high melting and boiling point. So here lower melting and boiling point. So if you learn one side of this table, then you can easily write the next side of the table. So maximum you should learn 5 characters from each side. Minimum 5 characters. Okay. You should learn. Next character, they are least reactive. But alkali metals are highly reactive metals, we know that. But from the alkali metals, lithium is the exceptional case because of this distinctive properties or the behavior of lithium. Its reactivity is less. So when they can combine with the oxygen. Lithium can combine with the oxygen and they can form oxides, normal oxides. Okay, and also they can form the peroxide with great difficulty. That means it is very difficult to form the peroxide with lithium and oxygen reaction. And also they can form higher oxides, but that higher oxides are unstable. So the reaction between lithium and oxygen form oxides and peroxides. But the higher oxides are unstable. So here we said the lithium character is least reactive. For the other metals, it may be the high reactive. They are high reactive. So next character, they react with the nitrogen and they produce here lithium nitrate. Okay, so lithium is a least reactive one, but other metals are high reactive. In this character, lithium can react with the nitrogen, but the other metals like potassium, sodium, rubidium, cesium, they are not react with the nitrogen. So they combine with nitrogen and produce lithium nitrate. There is no reaction with the alkali metals, have no reaction with the nitrogen. The next character is they can react with the bromine, but in the slow mode or in the slow reaction. Reaction with bromine is slow. In the alkali metals, they have reaction with bromine. They can react with bromine, but it is violent reaction. It is a violent reaction. Lithium can able to react with carbon directly. So they react with carbon directly. Direct reaction with carbon. And the reaction for this reaction with the carbon can form ionic carbides. For example, 2 lithium combined with 2 carbon, they produce lithium carbide. Okay, so they can form ionic carbide. So this is opposite for the alkali metals in group 1. They are not reacting directly. Reaction with carbon. But they can form the carbon compounds. For example, sodium is combined with C2H2. This is ethane. Okay, so this is carbon compound. So sodium is a group 1 compound. It is combined with the carbon compound, but it is not directly reactive with the carbon like lithium. Okay, this is directly reacting with the carbon, only carbon, but here it is combined with the carbon compound and they can produce the carbon compound also. So Na2C2. Seventh comparison, they are sparingly soluble in water. They are not totally dissolved in water, but they are sparingly soluble in water. This is highly soluble. The last comparison, lithium nitrate decomposed to give an oxides. Okay, so lithium nitrate are decomposed to give oxides. Other nitrites are decomposed to give nitrites. Nitrites. They can give oxides, but they are nitrites. This is the difference between lithium and other metals is present in group 1. And the next, lithium contains some distinctive properties. They can behave like magnesium in the diagonal relationship. So they have some similar properties with the lithium and magnesium. We can explain this in one table. Similarities between and magnesium, lithium and, so they are in the diagonal relationship. You know that they are in the diagonal relationship. So they have some similar properties. So lithium has some similar properties with the magnesium. We are going to see this in this table. You know that lithium is a hard element or hard metals. As like lithium, magnesium also a hard metal other than the metals which is in their respective groups. So they are hard elements or hard metals. Both are hard elements compared with the other elements in their respective group. The reaction with water, in the reaction with water, they are react slowly with water. Both are, okay, lithium and magnesium are reacting slowly with water. Their oxides, that means lithium oxide, magnesium oxide, lithium hydroxide, magnesium hydroxide, they are much less soluble. Okay, and their hydroxides are decomposed if you heating that decompose. Because of the heating process, lithium hydroxide and magnesium hydroxide decomposes. Because of this heating process, lithium hydroxide and magnesium hydroxide, they are getting decomposed. Means they are splitting. Third character, third similarity, both can form nitride. Okay, they can form nitride. So what are the nitride? Lithium nitride and magnesium nitride. Okay, so these are lithium nitride, this is lithium nitride and this is magnesium nitride. So the reaction between this nitrogen and lithium, nitrogen and magnesium, it is direct reaction. It reacts directly. They are not form any superoxide, but they can form oxides, like not form superoxides. They are not form superoxide, but they can form oxides. So what are the oxides? Lithium oxide and magnesium oxide. Next character, due to the heating process, lithium and magnesium carbonate are decomposes and they produce the result, or they produce the products like oxides and carbon dioxide. So decompose in the presence of heating. By heating, carbonate of lithium and magnesium, and the product oxides and carbon dioxide. Lithium and magnesium, they do not form bicarbonate, but they can form carbonate. Okay, so the next character, so this is same for both. They do not form bicarbonates, but they can form carbonates. Both lithium and magnesium chlorides, okay, lithium chloride and magnesium chloride, they are soluble in ethanol. That means soluble in organic compound. Ethanol is an organic solvent, so they can soluble in ethanol and they have the capacity to attract the water particles. So that character is known as deliquescent. Okay, so deliquescent means what? They attract water molecule from the other solvents. Okay, so if they attract the water molecules, they will become hydrated crystals. So they can attract water molecules. So this character is deliquescent. Deliquescent character. So because of this deliquescent characters, this lithium chloride and magnesium chloride is attracting the water molecules and they become the hydrates of that particular compound. Okay, so lithium chloride with the water molecule. Okay, so this is one crystal from the aqueous solution of hydrates. Okay, hydrates of aqueous solution. Then magnesium chloride attract water molecule. So the differentiation between lithium and other metals, then similarities between lithium and magnesium, both are important questions. So study at least 5 for each question, 5 points for each question. Then the next topic, diagonal relationship, is also a distinctive behavior of lithium. So lithium diagonal relationship. So diagonal relationship, lithium is actually diagonal relationship with the magnesium because they are placed diagonally in the modern periodic table. So similarities between the first member of group 1 is diagonally placed with the second element of group 2, that means magnesium. So lithium is diagonally placed with the magnesium. So this relation is known as, or it is called, diagonal relationship. This is why they are placed in the diagonal relationship and why what is made them to become in the diagonal relationship. So this is because of the size. So their atomic size is similar. It is with the comparison it is similar, and they have comparable electronegativity. So their atomic size and electronegativity is similar in both the elements. So you learn about the alkali metals, their physical properties, and the comparison, the distinctive properties with of lithium, and how they are diagonally related with the magnesium. Now we are going to discuss the uses of alkali metals. You have one more topic, chemical properties of alkali metals. We will discuss that topic in the next class. Today we will discuss uses of alkali metals. You know that lithium is a hard metal compared with the other alkali metals. So we are using this lithium for making or preparing alloys. So first property, for preparing alloys. Alloys means combination of two or more metals. For example, for combining this lithium with lead, we use this, or we call this lithium with the combination of lead is white metal. White metal. This white metal we use for the motor engines. Motor engines. When combination of lithium with aluminium is used for aircraft parts. The combination of lithium with magnesium is used for produce armor plates, which is used in the thermonuclear reaction. Second use is, lithium is also used for producing the electrochemical cells. So it is used in the electrochemical cells. Then third use, lithium carbonate is mainly used in the medicines. Lithium carbonate. In medicines. Fourth use, we use sodium. This is also an alkali metal. The sodium is used to make sodium or lead alloy for produce BbEt4 and PbMe4. So these organo-lead compounds are used as anti-knock additives in the petrol in the previous day, because it's the petrol combined with the lead component from the petrol, it is not removed from the petrol. That's why we used this sodium to prepare the sodium is using here to prepare the organo metals or lead compounds, organo-lead compounds, to use as a anti-knock additives. But nowadays we use here is lead-free petrols. So there is no use of this organo-lead compounds. Next use, liquid sodium is using as a coolant. Liquid sodium is using as a coolant in the fast breeder nuclear reactors. The first reaction which is kept in the nuclear reactor, there we use the liquid sodium as a coolant to absorb all the heat which is produced in the nuclear reactor. And potassium is behaving, or it is playing the vital role in the biological system in potassium sodium pump. Potassium chloride is using as a good fertilizer, and potassium hydroxide is used to manufacture the soft soaps. Okay, and also this potassium hydroxide using as a excellent absorbent of carbon dioxide. So it can easily absorb, this potassium hydroxide can easily absorb carbon dioxide. So the last use of this alkali metal, cesium, is using to devising photoelectric cells. So it is using here, cesium is using in the photoelectric cells. Cesium. Today's topic over. Thank you, students. Study well.